Analysis of risk. Nature and quantification of risk. Risk analysis in management accounting involves identifying, measuring, and evaluating uncertainties that affect project outcomes and organizational performance. Unlike sensitivity analysis, which isolates variable impacts, risk analysis integrates probability and consequence into a unified assessment. Quantification involves estimating expected monetary values, EMV, and assessing the variance or standard deviation of potential returns. This statistical approach enables comparison between alternative projects on a risk-adjusted basis. CIMA highlights that quantifying risk transforms uncertainty into measurable probabilities, facilitating objective decision-making. Risk analysis also supports capital budgeting by integrating the likelihood of achieving forecast outcomes. By applying risk-adjusted discount rates or certainty equivalents, financial managers can align investment evaluation with corporate risk appetite, balancing opportunity with resilience. Use of probabilistic models. Probabilistic models, such as Monte Carlo simulations, expected value calculations, and probability trees, allow decision-makers to interpret the distribution of potential outcomes rather than relying on single-point forecasts. Monte Carlo simulation generates thousands of randomized outcomes based on input distributions, producing a probability density function for project NPV or IRR. This approach enables managers to visualize risk exposure and assess the probability of negative returns. Expected value, EV, models summarize this information into a weighted average, providing a single performance indicator that reflects both risk and return. CIMA advocates for these models because they improve decision quality under uncertainty, particularly for long-term or high-capital projects. They also provide transparency to stakeholders by quantifying downside risk and confidence levels associated with forecasts. Decision trees and sequential decision analysis. Decision trees are graphical tools used to evaluate sequential decisions involving uncertainty. Each branch represents alternative actions, possible outcomes, and associated probabilities, culminating in expected monetary values. By mapping different scenarios, decision trees allow managers to visualize both immediate and future consequences of strategic choices. For example, a company might face an initial investment decision followed by a contingent choice depending on market response. Decision trees quantify these options, helping identify the path with the highest expected return. CIMA stresses that decision trees are especially useful for complex, multi-stage projects, such as R&D or product launches, where future flexibility matters. They also facilitate communication between financial analysts and operational managers by presenting risk information intuitively. Stress testing and scenario evaluation. Stress testing forms an integral part of risk analysis by simulating adverse events that could jeopardize project performance. This involves identifying key vulnerabilities, such as commodity price shocks or demand collapses, and evaluating their impact on profitability. Stress testing complements probabilistic modeling by focusing on extreme but plausible conditions, ensuring that decision-makers understand downside exposure. It supports contingency planning, allowing managers to develop fallback strategies such as revising project scale or adjusting financing structures. Stress testing also helps validate model assumptions by highlighting whether forecast outcomes remain realistic under pressure. CIMA views stress testing as an essential governance mechanism, promoting transparency and prudence in investment appraisal. By embedding it into capital budgeting, firms ensure that financial resilience forms part of every major project evaluation. Decision-making under uncertainty. Decision-making under uncertainty requires choosing between alternatives where probabilities of outcomes are unknown or imprecise. Techniques such as the Maximin, Max-IMAX, and Minimax regret criteria help managers evaluate decisions without full probability data. The Maximin criterion appeals to risk-averse decision-makers, focusing on minimizing potential losses. Max-IMAX suits risk seekers aiming for maximum possible gains, while Minimax regret minimizes potential regret from suboptimal choices. These methods provide structured rationality when probabilistic data are unavailable. CIMA advocates using these qualitative decision rules as preliminary tools before applying quantitative models. Combining them with sensitivity and scenario analyses enhances robustness. Decision-making under uncertainty, therefore, blends statistical reasoning with managerial judgment, ensuring that decisions remain aligned with corporate strategy and risk tolerance. Integrated risk management and strategic application. Comprehensive risk analysis goes beyond numerical evaluation. It integrates strategic, operational, and behavioral dimensions of uncertainty. Effective systems combine quantitative tools, like probabilistic models and decision trees, with qualitative insights from stakeholder assessments, market intelligence, and managerial experience. CIMA emphasizes that the objective of risk analysis is not to eliminate uncertainty but to manage it intelligently. This includes setting appropriate risk-adjusted discount rates, establishing contingency budgets, and embedding feedback mechanisms to monitor outcomes post-implementation. Ethical governance requires transparent communication of risk assumptions to stakeholders. In practice, integrated risk analysis supports value creation by linking risk management with capital allocation and performance measurement. It transforms uncertainty into a source of competitive advantage through informed, resilient decision-making.